Welcome back to the Ergo Blockchain Crash Course video series. This is the Ergoscript Development Fundamentals section. So what are we going to cover in this video? We're going to cover multi-stage protocols, Ergoscript Fundamentals, and design considerations if you're a developer. So the first section on multi-stage protocols. So within the UTXO model and within a transaction, we have only access to our local state. So within the context of a transaction, we only know about the inputs, the outputs, the context extension variables, and other information that's really associated only with the transaction itself. We don't have access to knowledge about other transactions in the block. And we can sort of define these with different levels. So in a level 1 system, you'd have only access to the current UTXO, for example. In level 2, it would just be the current transaction, so inputs and outputs. And then in level 3, we'd have access to the current block header, and also all of the information from the previous 2 levels. And level 4 would give you access to everything in the current block, so other sibling transactions. So Ergo, we would call, since we only have access to local state, we'd say it's a level 3 blockchain. So what is a multi-stage protocol? So when thinking about protocols for a dApp that you want to build, most of the time, doing everything with just one smart contract won't actually work. A dApp protocol consists of multiple smart contracts, while the state of the protocol changes from one transaction to the next. So in some sort of way, you can think of your protocol as sort of some sort of state machine, where the inputs to the protocol are boxes with a certain contract, and the different states correspond to what the new outputs become. So for complicated protocols, you may need to have multiple stages in your protocol, and these would occur in different transactions. So multi-stage protocol, we're going to cover Turing completeness, so of the Ergo blockchain. So Ergoscript language itself is not Turing complete. You can't do like infinite loops, like while loops or for loops in Ergoscript. You can't do that. But the Ergo blockchain can be used to chain transactions from one UTXO to the other and from block to block. So, and we can use this property to emulate this cellular automaton rule called Rule 110, which defines how to like update the next sort of iterations of the cells based on the neighboring cells. And you can look this up on Wikipedia. And since Rule 110 is mathematically proven to be Turing complete, by implication, so too is the Ergo blockchain, since it was proved in this paper from Alex that you can use the blockchain to emulate this Rule 110, and so it's therefore Turing complete. So you could, in theory, run any program you wanted on using the blockchain, and then you could think of like different iterations or steps in the program as like other transactions. So in practice, this isn't really useful. Like you're not gonna try to run, any program you want. It won't run Crisis. But it is useful to think when you're developing a protocol that you can think of like the different steps in the protocol as like different transactions that occur over time. So now we're going to cover some high-level Ergoscript fundamentals. So what is Ergoscript? So Ergoscript is the high-level smart contract language for the Ergo blockchain. The syntax is a subset of the Scala syntax, and Scala is just another programming language, and if you read Ergoscript and you read Scala, you will notice some similarities in the way it's written. The low-level language is called Ergo tree. So when you write Ergoscript, it will then get compiled to Ergo tree. It is possible to write smart contracts in Ergo tree directly, but it's difficult. That's why the higher level language Ergoscript was created, so it would be easier for developers. Ergoscript language, it gives you the tools to control and access all the components of a transaction. So this is why I sort of wanted to teach the concepts about the blockchain, the UTXO model, before explaining what Ergoscript was, because the two are sort of linked together. Any sort of information about the local state of the transaction, Ergoscript gives you the power to sort of use that information and access that to write your contract. So you have access to the block header, data inputs, context extension variables, outputs, all the box contents in the registers, and other advanced cryptographic features. Ergoscript is a functional language, so all the variables are immutable. And it's very simple. There's not, nothing crazy going on, but it lets you do really complex things, which is really cool. So these are the different data types that are available to you in Ergoscript when you're writing your contract. Sort of the Bible reference is the Ergoscript language specification, which is just a markdown document that explains about all the different data types, the different classes available to you for the different objects like boxes, and then all of their methods and any other function in Ergoscript that you have access to. It's defined there. When you compile the contract, like I mentioned in the first section, the UTXO model review, you can sort of think of the contract as the validator function, and this validator function must evaluate to a Boolean value, either true or false. If it's true, then the contract evaluates the true, and you are able to spend the contents of the box. And what's cool about doing it, about it working this way, is that a contract is essentially just a bunch of propositions that must be checked to be true or false. So what is the transaction context? So like I mentioned previously, the validator function must evaluate the true. The context gives you access to the transaction information. So the height, the current box, you can reference yourself, the current box in which the contract you're writing will be in, the outputs, and then the data inputs. And there's a keyword called context, which lets you access all of these things. But since the height, the self inputs and outputs are the most common, they're also given their own global variable. So how would you use Ergoscript to access the box registers? So first you would say, I want to create a box called my box, and you would have to say, where is it in the inputs? So in our case, it would be the first input of a transaction. So we would access that by accessing element 0 of the inputs array. And just like I mentioned in the UTXO model review, the anatomy of a box section, we can access the different registers in the box. R4 to R9 are the ones with the custom data that are a subset of the any type in Ergoscript. And then the first 4 are the predefined ones: the value, the proposition bytes, which is the contract in byte form, the tokens, so whatever assets in the box, and the creation info. And so by doing this, since we're able to access data in registers, we can use this information in conditions to check that the correct data that we want is actually inserted in the register. so we can check for like equality. And then why would you want to store data in registers in the first place? Well, it's a way to persist data across different transactions from one state of your DApp protocol to the next. And so that's obviously there's many other use cases, and it's very flexible. Like I mentioned, we also have context extension variables. So unlike regular variables, these get inserted into the box during the transaction building time, not when the contract is compiled in the first place. So if you want to access a context extension variable in your Ergoscript, you would use the getVar function, which tells you sort of the data type that the variable is supposed to be, and then which position is it in the sort of variable array. So each box can not only have one context extension variables, but it can have multiple of them. So if you put all of the variables in a list and you want to access the specific one, you have to know which location it will be in. And as a developer, since all of this is just in code, you would know which position it is when you insert it into the box with the off-chain code. So contract evaluation. So like I mentioned, the Ergoscript contract must evaluate the true in order for the bucks to be spent. The final statement must be either true or false. And all contracts must end with the statement sigma prop. And inside, it takes some Boolean value, so a proposition, and it will return either true or false, letting you spend the box or not. So in this silly example, we're accessing your public key, which should be in this box itself, and that's a sigma proposition type. So any address that you want to access, you can access it as form of sigma prop type or as the proposition bytes. Then we're also accessing your current balance, which is in self.r5. And then we're going to create a new output box. And if the new output box's value is greater than 1000x your current balance, and the new box is the same the same address as your current box, so the proposition bytes is the same contract, then you are rich and it will be evaluated true. And then we also want to know about a context extension variable, which will be a true or false statement, and it will let you know if you are still paying attention or not. And if you are both rich and still paying attention, then you will be able to spend the contents of this box. Otherwise, if you are not rich and you are not paying attention, you are still able to access the funds in this box, nonetheless. And so, like I said before, you can think of the contract as just a bunch of propositions that must evaluate the true or false. And this is literally what we have done. We have just written a bunch of, just two propositions. And with the Ergoscript language, since it gives us the tools like to access the different information in the transaction context, we're able to use that to create our propositions that we want. And at the time that the transaction gets sort of executed, these conditions will be checked, and if they are satisfied, then we can spend the box. And now we're going to cover about costing. So there are two different types of costing in Ergo. There's ahead of time costing and just in time costing. So ahead of time costing, what occurs is when the cost gets calculated at the time of transaction execution, if if your contract contains any branches, so like if else statements, then all branches will be checked. So this can lead to some errors like missing variable not found. In the case where in one branch, if the condition wasn't satisfied, then some variable gets used, is sort of defined and gets used. But then if in the other branch, since the condition wasn't met, then some other variable is used. Since the both branches don't have the same, is missing, one of them is missing the variable, you have to create the variable and assign it some dummy value that you, even though you're not going to use it. And just-in-time costing, that's being implemented in the Node version 5, and this brings improvements so that in the case of transaction costing, this problem won't occur. Only the correct branch will get evaluated. Now we're going to go over design considerations. So when you're starting out a design, the first thing you're going to want to think about are your requirements. So before writing any Ergoscript code for any complex protocol, it's a good idea to know what you're actually supposed to do. So what is the protocol going to do? What are the different transactions involved? What data is being transferred from each stage in the protocol? How is the user supposed to interact with the protocol, and where? Since in some sections, a user needs to send money to some contract, and then in other sections is just sort of the protocol happening in itself, and there's no user involved. And then what needs to happen on chain, so in Ergoscript itself, and then what are you going to be doing in the off-chain code? Another useful tool is to create protocol diagrams showing what inputs and outputs are involved. And this helps you to understand what boxes are involved in your protocol and also what data they contain. So when you're designing your protocol, you're going to be writing Ergoscript, and then it's also useful to sort of outline the boxes themselves so you know what data types are in it, and then you can calculate the size since you know the data type, and you can have an idea of like the size of the box and the contract itself. And as well as same for the registers in the box, since you want to be able to know ahead of time what, like if you'll exceed the register size limit for the box in total. And then the purpose of all of this is to understand the limits of your system. So you want to be able to know, like, am I exceeding the size limit of the box? How can this protocol scale if more users are involved? So more transactions, more boxes. And what are your constraints? Because you can write a contract that works technically, but then if multiple people start interacting, then what happens? And then does your design fall within the limits of transaction cost? How does it deal with ahead of time and just-in-time costing? So why do all of this? The purpose is to understand the limits of your system, and this will make you a better designer and ensure that you're designing with the user's safety in mind, which is supposed to be your number one priority, and not burning their tokens or siphoning their funds by accident. And this is just engineering professional practice 101. So be responsible. So when you're designing a protocol, what are some common design patterns that you might encounter? You'll encounter the concept of the self-replicating box. So it's a box that's recreated with the same contract, but with the data in it has been modified in some way. So even though boxes have their own box ID, and once a box is spent, it can no longer be used in another transaction, you can create an output box that, even though it'll have its own different box ID, since it'll be at the same contract, it's effectively as though it's the same box in some sense, but you've changed the data in it somehow. The second one is a config box, and this is also usually can be a self-replicated box, but sometimes it isn't. And this box is used usually to change something in a protocol. So it'll hold some settings or parameters that can then initiate some change in a particular stage in your protocol. Then we have the singleton utility token. So even though this is not a box, but the token itself can be used to reference and keep track of a particular box. So like I mentioned, the box, when you create a new box, it'll have a different box ID. So how do you know what boxes to keep track of? If you only want to know specifically about one particular box, then you can create a singleton token. So in that sense, it's kind of like an NFT, but there's no like art attributed to it. The purpose is just to be used as a reference or a pointer. The next idea is like transaction chaining. So you can use outputs of previous transactions and use them as inputs to another one directly within your off-chain code. And so when you submit everything to the blockchain, if the first transaction in the chain doesn't get confirmed, then the following ones will not get confirmed. But the advantage of using transaction chaining is that you can then, in your code, create more complicated protocols that involve previous boxes. And then finally, parallelization, which just takes advantage of the UTXO model in itself, since each transaction can have multiple inputs or outputs. So it's as though you're doing things in parallel, even though there's only one transaction. And then this idea can also be used to simplify your contracts. So instead of doing everything in one Ergoscript contract or in one box, you can split up the tasks between boxes and then I'll use them as inputs into one transaction. So these are some design constraints, some actual numbers you might have to be aware of. So we have the total transaction size, which is 95 kilobytes. So this is data in the registers of all the boxes, the input boxes into the transaction, but then also the context extension variables and then your size of their contracts and everything. The context variables will be whatever is left over. So you could do like 95 minus the box size and the variables, and then whatever is left is what you could use for context variables if you wanted to include them. The average block time is 2 minutes. The current miner fee is 10 million nanoerg. The computational cost is 5 megabytes. And then this was reduced to 2 to 3 megabytes in version 5 of the node. So we have less computational cost available to us in node version 5. But the other improvements that the node version 5 brings sort of offset this reduction. We have the minimum erg for existence. So currently it's 369 erg per byte. So it's the transaction fee per byte. The minimum is 0 and the maximum is 10,000. Storage rent is 1.2 million. The minimum is 0 and the maximum is 2.5 million. And these parameters can be changed via miner voting. And then an important sort of note about storage rent is that after every 4 years, since their tokens and the erg in the box get recycled, if it doesn't have enough erg to pay the transaction fee, if there's an important token in the box, then this might be a security risk, depending on the purpose of your application, since now this token, it belongs to some random miner. When you're designing your protocol, another important thing to do is to write a protocol specification. So this is essentially just a design document that explains what is going on in your protocol, the different stages, the different possible spending paths, and the different contracts for each box in a stage. So what is a stage? So think of that as just as a box at a particular point in the protocol that is reached by the user. An action is what the user can do in order to progress to the next stage, and a stage can have multiple of these actions. So, and then action conditions, these are the conditions that must be satisfied in order for the action to proceed. So the different possible spending paths, depending on what your propositions are that you wrote in your Ergo script. So what are some common stages of development? So obviously there's your requirements, you outline all your project goals and design needs. The protocol specification, so you try to outline your protocol so you can explain it to yourself and other people. There's the on-chain code, that's all the Ergoscript logic that gets verified. And then there's the off-chain code, which is all the computation that doesn't occur on the blockchain. And then the front end, usually, if you have one, that interacts with your off-chain code somehow. And yeah. So an important consideration is scaling. So when you're designing your protocol, initially you want to know if your protocol will be able to scale to multiple users. And scaling can apply to just as much as the on-chain code as it does to the off-chain or front-end code. So typically, you think of scaling. How am I writing my code? Will it run on multiple processors? Like how do I threading and things like that? But there's also the transactions themselves, the boxes within the transactions. Like how does that scaling work, and how are you writing your Ergoscript in such a way to take advantage of that? So, for example, how do you scale your protocol if you need more than 4 kilobytes of data in your box? Do you need to use the Plasma library, which lets you use AVL tree as a data structure to store data? Or do you need, potentially in a layer 2 solution if you're dealing with high transaction volume? So you need to process a lot of data, not only a lot of data, but many transactions all at once. How does the transaction behave when there are multiple boxes in the same contract, with the same contract? So, for example, if some transaction consists of inputs only of boxes of the same contract, are you writing your Ergoscript such that you know to use all of the boxes in the inputs, or are you only checking one box with the same contract? Because this can mess up the logic in your code. And how much computation is needed in your Ergoscript? So does it increase when more inputs and outputs are involved in the transaction? So typically this is important when you're writing sort of the loop functions in Ergoscript for the fold, the for all, and the exists. So if you want to check if all of the input boxes have some token in it, then you might use the .forAll method, but it's going to need to loop all of the over the inputs. So if you have a lot of inputs, then that loop, is going to take up a lot of the transaction cost. So how do you spread out that logic, and how do you write it in a way to scale? Finally, we also have testing. So when you're developing on Ergo, there's usually 3 main ways to test. You can do off-chain testing, so debugging your code without signing or submitting any transactions to the blockchain. So you're running all of your logic up until the point that you need to sign. You can stop there and then test if anything fails. If you want to actually test your protocol on a real blockchain, then you can run it on testnet with all your fake money, and you can also test on mainnet, but you'll be using real Erg, and so any money you lose, it will be gone. So these are some common development tools you might encounter. The most common ones are Scala, Java, so that's for the apt-get library, and that's used to interact with Ergo directly. In terms of editors for writing code, you could use VS Code. That's a pretty good IDE. You have access to the Ergoscript language support extension for syntax highlighting when you're writing your Ergoscript contracts. IntelliJ, another really good one. There's no Ergoscript language support package, but you can go ask a Cheese Enthusiast. And then there's Scala Test for unit testing. And then the node, you can connect to your own testnet or mainnet node for testing, or use a public one. For production, it's best to set up your own node that people using your dApp will end up interacting with. On-chain scaling solutions, you have GetBlock Plasma library, so it lets you sort of deal with AVL trees in an easy way. And then you can also have your own local Explorer instance. So it's a personal instance of the Ergo Explorer in order to retrieve blockchain data more efficiently, instead of having to connect to a public Explorer, which may be slow depending on the volume. You can write your protocol, your off-chain code in Python. Some common libraries are the Ergo Python apt-get library from ErgoPad, the ErgoPy library from MGPy, but the main downside is that it has limited features for the more advanced features, so you can't use it to do AVL tree manipulation with Plasma, since it only works with the Scala. It only works with Scala. And then if you're more interested in web development, there is a web sort of JavaScript / Rust implementation of the Ergoscript compiler. So that's what Sigma Rust is. Ergo TypeScript is a library for interacting with the Ergo blockchain using TypeScript. And then there's a new one called Fleet that's being developed by Captain Nemo, and it's called the Fluent Ergo Toolkit. So the purpose of that is to create a pure JavaScript library that implements all of the functionality of apt-get. So it unlocks all of that power for JavaScript users. And hopefully this will help to onboard many developers. And then there's various dApp connector plugins for React.js to interact with browser walls. And finally, we'll cover ethics. So this is important as a developer, engineer, designer, and just a human being in general. So don't forget that you are involved with payment processing. You are messing with people's money directly, potentially. Be responsible, diligent, and judicious. Do not be reckless. Take your work seriously. It is a reflection of yourself. Be a professional. Don't be afraid to ask for help. The community is very helpful. There are no stupid questions. Remember to keep learning and have fun at the same time. We are all mortal, doomed to die. Nothing lasts forever. I'm going to die. You're going to die. Everyone you know and do not know and love is going to die. Everything is transitory. Nothing lasts forever. Entropy always increases. The death of the universe is inevitable. Therefore, while you are still alive on this earth, try and maximize freedom and minimize needless suffering. Thanks for watching, and please watch the next videos if you're still interested, where I'll cover examples.